All right. Well, welcome to this week's Kong Builders episode. I'm really excited to introduce a special guest from Red Hat today for this OpenShift Kong Gateway workshop. My name is Kat Morgan, and uh, I am not completely losing my mind trying to work a new tool today. So, that said, Casey, I'd like to welcome you. Thank you for joining us from Red Hat today. I know you've put a lot of work into really kind of showing off the best integration of Kong on OpenShift lately, and I thought it would be a great thing to be able to share with our mutual customers and anyone who's kind of scoping out those options for their needs. If you want to go ahead and introduce yourself. And I think I've got you. Yeah, your sound's not coming through, Casey.
Hey, can you hear me? Okay, so I just had to change my input. There's these three little dots at the very bottom, then go to settings, and then go to the audio. Yeah, cool. You can't hear me still? Or you can? Hello? Uh,
All right. If I can get in comments that you can hear me, that would be awesome.
hey, Kat,
Yep. Yeah.
can you hear me
So,
now?
Casey, I'm sorry. I know that everyone can hear both of us, but I
Okay.
can't hear you right now.
Okay.
Actually, Casey, I will work on that. If you actually want to go ahead and just kind of go ahead and kick it off. I know you have
Cool.
the reins ready.
Yeah.
We'll share your screen and let you take it away until I can get audio on my side too.
Cool. Okay. All right. So, Kat, thank you so much. It's a real pleasure to be here. And Kong and Red Hat are partners. So essentially, what we do together is work together to kind of make sure our mutually shared customers are having the best experience possible, looking for small improvements and efficiencies that we can do together to kind of make improvements all around. And this has been just a very mutually beneficial relationship over the past 3 months, just really digging into Kong Gateway, Kong Mesh, and Kuma. And it just so happens that today we're going to be talking about Kong Gateway. So what I've prepared for you all today is essentially we're going to be installing the Kong gateway on OpenShift 4.10, and we're going to deploy Istio's book info application. We're going to secure it. We're going to actually control east-west traffic inside of it. And I know we said gateway. Gateway is north-south. We're going to actually control east-west traffic as well through netpols, network policies. We're going to throw in some Keycloak to throw in some OIDC, really kind of protect our services. And we're also going to look at Kong's great rate limiting plugin. So let's jump into it. Here we go. So I'm going to essentially just click here, right? Going to do the prerequisites. So first, foremost, most importantly, create the namespace Kong.
Yeah, so I created that namespace when I was testing the binary earlier today. Also, my audio's back. I switched headsets and things just worked, so that's good.
Great.
Thanks for carrying the show while I was working that out.
No problem at all.
For everyone following along, I'm going to go ahead and drop a link that actually has some of these notes that Casey is basing his work off today. That's in chat. And of course, while we're going through this, if anyone has specific questions or you're curious to talk a little bit more in depth about any given step along the way that we're going through, feel free to call that out in the chat. We'll watch and kind of triage and make sure we include some of those talking points as we go along.
And one talking point that I should have brought up is you were seeing this K command. I did alias K equals kubectl before we started. So K is kubectl. All right. So essentially what have I done so far? So Kat made the namespace. I just created the generic secret for the license key from a file. So basically this is essential. This is important for using Kong Gateway Enterprise. Now, the very next step, what we're going to do right now is we're going to generate the private key and the TLS cert. This is going to be the cert that the gateway actually uses. So we're just using this x509 command to create the private key and cert. So that's created. Now we're going to create a TLS style secret, and it's going to be called Kong cluster cert in the Kong namespace.
Yeah, so in the chat, while you're going through some of those steps, I'm going to cover some of the questions. In the chat, we have a question about what is Kong Gateway? And actually, that's a really good question, because I know that we have a lot of OpenShift people who are maybe new to Kong or haven't come across Kong before. Kong offers a few different products. So we have an API gateway, a service mesh, and a developer tool called Insomnia. Today, we're focusing on the API gateway. And what that is the core of the product is a reverse proxy. So it's Nginx based. It includes OpenRecipe, which gives us dynamic control over Nginx configuration. And then Kong layers on top a set of plugins and management tools and fronts it with an API that controls the underlying components dynamically to provide all of the lifecycle operations that you might need to support multiple proxies from that centralized gateway, to include plugins to centralize your authentication configuration. So if you're using OIDC, integrating with Auth0 or Keycloak or other OIDC providers, you're going to see a lot of features for rate limiting or advanced rate limiting, caching, and the opportunity to write your own custom plugins, which we frequently do with our customers to make sure that we can support unique ways of handling traffic based on headers or all kinds session cookies and all kinds of other logic to control what traffic you're sending where, when, and how. So it's really, if you look at OpenShift, you might be familiar with the OpenShift router, and I think we're going to get into kind of just talking a little bit more about that and how we are connecting OpenShift router and Kong Gateway. But the Kong gateway starts at layering on more advanced opportunities for customizing how your traffic flows once it actually reaches your cluster. All right. And so Casey, it looks like we just... Oh, do we need to install Helm?
Yeah, I got it. Don't worry, I found it.
Cool. Awesome.
Yeah.
Yeah, so before the stream today, I built an instance that we're using as a Bastion host in AWS, and then I built an OpenShift 4.10 cluster. So that's what Casey's working on today.
There we go.
Sweet. And then sudo should be passwordless. So I think we'll be good there.
Cool. We got Helm. Yeah, so Kat was talking about the Kong gateway, right? And one thing we want to really kind of call into attention here is that gateways are north and south traffic, right? And what does that mean? That means from the user into essentially the ingress of the cluster. And best practice nowadays, right? This is 100% best practice. For essentially each namespace, each application, you should have a gateway, right? Because you want to have essentially what's called failure domains, like whether that be physical or logical. So in order to have everything kind of in its own realm and decoupled, each kind of application needs its own gateway. So you could technically have 10 gateways, right? So let's talk really quick what's just happened, because now we're gonna, our next step is to install the control plane, and we were all chatting. So here's what's transpired. So we've created the private key in the cert, right, for the Kong gateway. And then we created this TLS secret, which the gateway will use, called the Kong cluster cert. The very next thing is some very Kong specific tasks. We created the session config for the Kong manager in the dev portal. And of course, we create a secret out of that so that the Kong can actually get that in its reconciliation loop and pick it up. Next, we created a password for the Kong manager. We probably, or depending on what Kat says, we may or may not go into the Kong manager today. If we don't go into it today, I highly encourage you to check it out. It's a really, really good UI. It's very helpful too. And then basically the very last step is we're preparing ourselves to deploy the control plane. So we've added the Kong repo through Helm, and then we just updated our Helm. So here is where we start kind of getting in to the bits a little bit more and seeing some of the power of Kong. So we have our Kong namespace. So we're going to be installing this release called Kong from the Kong Helm chart. We are essentially going to be deploying a Postgres database. So this is how Kong's going to handle the configuration. And you can configure users. You have a lot of configuration that you can do, right? Because while this is it's an API gateway that's minimal and lightweight, it has a lot of functionality. So that's essentially the reason behind this Postgres database behind here.
Yeah, if I can actually cover some of the Postgres and why that's valid here. So Kong has the ability to run as a DB-less API gateway. And what that equates to is running purely from memory. But some of the power and value that a lot of companies find in Kong Gateway is the RBAC control. So being able to separate different developer teams by like logical groupings of roles, what APIs they have access to and maintain, possibly separating internal corporate developers from external API developers who might need access to your APIs to develop new features or consume those APIs. And all of those like logical groupings fall under the RBAC, or role-based access control feature. Anything that requires that RBAC capability, that's when we actually start needing the database backend as a stateful location to maintain and distribute all of that kind of configuration.
Thanks, Kat. So essentially, we just installed the control plane. The pods are coming up, and I know a lot of people are probably not familiar with OpenShift, but OpenShift has its own ingress, its own proxy at the ingress called HA proxy. And this command right here, it says OC expose service. I'm going to give you a very oversimplified version of what this is. Let's just say it's a way to expose the service to so that you can hit it from the ingress. So essentially what we have here, so let's say K get SVC and com. So we're going to look at our control plane services essentially right now. Let's see if we can make that a little better. Let's see, in com. All right, so it's a little small, but we can get the gist here. So currently we have this Kong admin service, the Kong cluster service, this is very useful if you're going to go multi-cluster. And I'll actually point out how to do that as soon as we install the data plane. But essentially this would be exposed as as a load balancer would be, my choice, but I'm sure you could do it as a node port and basically just hit the IP of the node. The cluster telemetry URL. Essentially, we're going to make these accessible from the outside using this notion of the OpenShift route. And that's the next command here. Exposing services as routes. So those are exposed. Now we can get the routes in Kong, and we're going to see there's actually URLs pointed to them. It shows which service they're pointing to, and it actually shows the port on which these services are exposed. And finally, this is kind of my own preference. You don't have to do this, but I would recommend it. When you're doing something that has multiple steps and it can get intricate, you want to actually wait for things to get ready. So essentially, we're waiting on the control plane pod to get ready. We're waiting on this job, and Kat, correct me if I'm wrong, but this job is to kind of prepare the Postgres, correct?
Yeah, actually. So init migrations is a pod that the control plane is dependent on. That init migrations initializes the Postgres database. And then you'll also see some other Postgres maintenance tasks. So if you do a Helm update or take some other update step in the lifecycle of your Kong gateway, you'll see some of those pods hitting the database. And that's just making sure that schemas that updated are converted properly in the database and handling maintenance of the lifecycle of the database over time.
Thank you. So yeah, essentially we're just waiting on those jobs to finish. You don't want to rush it. If you try to start doing steps out of order, you're surely going to kind of fall into a problem. And this kind of really goes into the whole GitOps workflow. So we noticed when we were actually installing the control plane, there is a ton of configuration there. That is needed. That's necessary because you want to configure every single thing in as few steps as possible. In case you're throwing this in Argo CD or some kind of GitOps engine, you want it to be almost as configured as possible before you kind of move on to the next step. You don't want to be patching things, for instance, if you don't have to.
Yep, absolutely. That imperative versus declarative model. Actually, while we're waiting for this to come up, or if before we move on to the next step, we have a question about how to install it in OpenShift, if it's an operator, if we're using Helm, or what our options are there. And that's a really good question because there are a few different ways to go about that. You can forgo the Helm install path. We are using Helm today, but things like Customize are fully supported. If you're looking at going the route of Argo CD or Advanced Cluster Manager, you're going to see an option for writing out all of your manifests directly or also using the Helm chart at that point. And then as far as a peek into the future, there is an operator in the works. It is pre-released right now. I think it's at least some versions of it are in the operator hub now, but we're looking at the Kong 3.0 or later release for actually bringing that operator to production ready. And what that operator is going to do is actually remove a lot of the human in the loop. So like Casey, you were saying, you want to wait until a task is completed while deploying the control plane before we move on to data plane tasks and other steps like that. That is that logic, that knowing when to wait and when to move on. All of those things are behaviors that are reasonable to code into an operator. And that's why we're working on the operator as we speak. All right, so where are we at now?
All right, so now we are going to actually validate that our control plane is installed by curling for the version. So essentially here, and how are we doing this, right? So this is a very important part. So the Kong control plane has this Kong and min service, right? And this Kong and min service is essentially responsible for handling the control plane configuration. So we're going to actually curl this to see which version we're on, and we expect to see 2.8 point something enterprise. So let's just look at this. And here we are. Great, so getting a credentials error. Let's try this again. Actually, I need HTTP pi, so that's the next step I'm gonna do. 1 second.
So there's different ways to interact with the API. Right now we're on a pretty new instance in AWS, so I don't think we've installed everything that we're used to having handy. Curl, HTTP pi, they're both CLI tools for interacting directly with an API.
Maybe I can use pip. That would be easy.
I have you out of your element on an Ubuntu instance, don't I?
That's okay. I just need to find how to install HTTP pi.
It should be. I wonder if it's just not in a normal repo. That's weird. Or might need to update the repo list before. There we go.
Oh, there we go.
Okay.
Nice. Save the day. Okay, cool. Thank you. All right, so essentially we're just checking against this Kong and min route, and we're essentially looking for the version. As you all saw earlier, this is now protected by a token. So we want to just make sure that only authenticated users are essentially talking to the control plane. The users that we want to be talking to the control plane. So essentially earlier I said we were hoping to get that 2.8.0 Enterprise Edition back, and that's exactly what we got. So we're moving on. So for the Kong Manager UI actually needs to be patched, and it doesn't always need to be patched. It needs to be patched kind of in OpenShift because we want to tell essentially the control plane where is this route. So where do I look for the API URL? And we're saying you look at this route, and this is where it is. So that's what we're going to tell it, just where to look.
That's clever. I like that one-liner.
Thanks. Now, every time I do anything, it's validation, validation, validation. So I'm just going to actually look at that deployment, and I'm going to look at the containers, grepping for that environmental variable on the pod, just to make sure that route's showing right here, which it is. So that's good. Okay, so we are all good on the control plane. Still kind of running through the scaffolding. Got to get the data plane up, and then we'll get into our fun stuff. But so you can deploy the control plane and data plane in the same cluster or two different clusters on a VM. I mean, the deployment options are vast, almost endless, right? And that's a really great thing about Kong, right? Because you can offload workloads on VMs. So it kind of caters to the hybrid cloud, which is essentially Red Hat's mission too. So it's kind of a match made in heaven, I guess, or just a great match made.
I like to think so.
Yeah. So here we're going to create namespace Kong data plane. We're going to copy our license secret from before, because you always need a license secret to interact with Kong Gateway Enterprise. And now the exact same thing as before, the TLS cert, which will be used by the gateways.
So yeah, this is a separate Helm release. So what we deployed earlier was just that control plane piece, and then this is one of however many separate data planes you want to deploy. You can actually separate it out by different namespaces and isolate those data planes to those individual namespaces. You can break it out into a different cluster. And I think, Casey, you kind of mentioned that earlier. So really, this is one example of how to deploy a data plane and connect that up to a control plane.
Yes, that's exactly right. So earlier, I was actually pointing at this service in the control plane called Kong Cluster Service. CC, and let's look at it really fast.
Yeah.
Kong. Wait. Okay. Here it is. This Kong Cluster Service. So here, when we're connecting the control plane to the data plane, we're actually going to reference this URL right here through this environmental variable. This just as easily could be on a separate cluster, and this URL, so this is a local cluster DNS. This would be the URL, for instance, of a load balancer. And likewise with the telemetry, right? It's the exact same host, just one's port 8005, one port's 8006. So essentially what you do to go multi-cluster immediately and just put these two things on two separate concerns, essentially now you have two different failure domains that are not coupled, right? So if you think about kind of resiliency, that's the way you're starting to go when you do things like this. But yeah, simply just expose this service, the Kong cluster as a load balancer, expose the Kong cluster telemetry as load balancer, give it the ports, and that's all you need to do to go multi-cluster for a start.
Yeah, just kind of adding to the idea of multi-cluster with a centralized control plane. One of the really fun new things that Kong just released last week, actually, is the Connect Cloud. So it takes that paradigm of separate global control plane, and we offer that control plane as a SaaS. So one of the most complex parts of Kong is actually deploying and maintaining that control plane component. And then the data planes from there that you deploy out are relatively simple in comparison. And so that SaaS Connect product, where Kong hosts the control plane for you, gives you that global pane of glass in the cloud. And then you connect data planes all around the world in multiple clusters, in cloud clusters or on-prem. And then you have that single unified view in the cloud for actually connecting up. This is that, of course, self-hosted control plane.
All right, so check this out. We've just deployed our data plane, right? We waited for the pods to come up. So we just had this little wait timeout, and the conditions were met. So the data plane looks good. We then curled the data plane proxy directly. And it is said, maybe confusingly, maybe not confusingly, hey, no route match with those values. So I can't go to / on the data plane proxy and expect it to do something. Why? Well, because we haven't created an ingress yet, and there's another way to do this. Like you can actually essentially configure the Kong control plane through REST. So there's a lot of ways to configure it. At this moment, we just haven't configured it yet, and that's the next steps. But that's why we're getting that no route matched. And this is our next step. we're essentially going to check the clustering status. So this is kind of Kong's way of telling you, hey, the control plane and the data plane are in communication and they're in sync. So let's go ahead and check this just to make sure we're in sync as we expect to be right now. And we are. So we can see this is actually our data plane host, and we're good and we're talking. And and that's it for the control plane and data plane installations. Now we're going to start with the app scaffolding and then start doing things with the gateway.
So yeah, that no route found was failed successfully, right?
Yeah, exactly. Yeah, I should have got the status code on there to make it even simpler, right? So there's this really genius app, Book Info. And I say that not as a joke because I love Book Info. It's a great app, and you'll see why, because it's so good for teaching, so good for doing multi-cluster. You can do canary releases with it. You can do blue-green deployments with it. It's just a tool. It's a great tool. And in Kubernetes, Kubernetes and cloud native, hybrid cloud, you need to have separation of concerns. You need to separate failure domains. One very small logical failure domain is by namespaces. So anytime we're doing a new app, we put it in its own namespace. So this is the book info namespace. We're having its own app. One thing about OpenShift is what we call secure by defaults. So if you're familiar with validating admission controllers, validating and mutating admission controllers, the admission controller is essentially what sits up at the very front of the proxy and accepts the requests as they come in. And these are the requests basically coming in from like your kubectl client. It wants to see a very, very secure manifest, right? And if it's not secure, for instance, if you're running as roots, or if you're running with like an FS group, or if you're running as user, less than like, I don't know the exact number, but if you're running as a low user with a lot of permissions, or you're running as a group that needs a lot of permissions, it's not going to like that, right? And why is it not going to like that? Because you can technically, if you have enough permissions, if you can escalate privileges, you can reverse out of your shell and get onto the host machine, and you could really do some damage, right? You could do a ton of damage. You get the AWS creds, crazy stuff happening. So, yeah.
Yeah, so one of the things about OpenShift that sometimes gets a bad rap is the fact that some of that security context stuff can feel like it's really getting in the way of being able to accomplish something successfully. But when you look at the legitimate risks that mitigates in a production scenario, the confidence in your security posture that brings to like just your confidence in production and facing the open internet, it really is worth learning, understanding, and utilizing as a tool to prevent crisis in the future, right?
Yeah, agreed completely, right? And pods, you need a very powerful kind of validating controller at the cluster level, whether that's like OPA, whether that's pod security policies,
Hmm.
whether that's exactly how OpenShift does it. Doesn't really matter what it is. It just has to be done, right? You have to have
Yep.
security, and you also need network policy, right? You need to fence things off. You need to say A can talk to B, but there's no reason for A to talk to C, right? They shouldn't even communicate. So you want to go ahead and fence things off with these, again, failure domains, logical barriers, separation of concerns.
Exactly.
All right, so I just deployed book info in the book info namespace. So we'll get the pods and book info. And we have our details application. We have our product page, our ratings, our reviews. And I'm actually going to show everyone a picture of this architecture, because this pretty much means nothing just looking at the pods in a namespace right now. But they all speak with each other in a microservices way that makes this a really good use case for kind of showing off the power of Kong and network policies to really kind of lock it down, right? Because we're pretending that book info is our production app right now, or at least kind of production like. So we want to secure it a little bit. We noticed there's like reviews version 1, reviews version 2, and it would be nice to do like canary rollouts or progressive rollouts and kind of blue greens, but it's just not really what we're doing right now. So I'm going to just delete those.
plans for the future, and a great opportunity to show off things like mesh and stuff too when we get to that someday.
Agreed completely. Yeah. So here's where we essentially are right now. We have this service. Let's get my services. All right. So we have this product page service. For all intents and purposes, product page is where the user is going to go. So product page, and before we'll go back, just ignore everything right now. I want to show you all something. Here we go. This is what I want to show you all. All right. So what's going to happen here? This is the request path. The request path lands on this product page, this Python app. It doesn't even matter what it's written in, right? It's all microservice architecture, so it doesn't even matter what it's written in. Product page talks to reviews, right? So basically, it's got two panels. It's got this book reviews that says like, hey, this book was great. And then reviews talks to ratings, and the rating shows the number of stars the book has. And then also in that product page on the left pane, there's like these details about the book, like, hey, this book was written 1995 by this person, etc. So this is important. So product page talks to reviews, reviews talks to rating, product page talks to details. These are the really only communication we need.
I actually wanted to ask you a little bit about how you went about designing this networking path. So
Yeah.
in OpenShift, a lot of applications go directly through the OpenShift router before they reach any services, right?
Yes.
And when you're adding another layer like an API gateway, you have the option of serving that API gateway, which is that data plane proxy component, directly to the internet behind a load balancer or like a GLB or something like that.
Yes.
But you also have the option of tucking it behind the load balancer and OpenShift router that you already have networking built up for. How did you go about designing that today?
So I didn't put it, but basically I wanted to expose it on its own to kind of take out the complexities. And
Okay.
it essentially what I'm looking for is I'm looking for like functionality for like timeouts and retries. I want like some really in-depth routing protocols. I want rate limiting because I want to protect my critical infrastructure. So you know, that probably didn't really answer your question, but it was just the easiest way for me to do it. Is
So
the
yeah,
honest answer.
so today we're showing the API gateway connected directly out on its own load balancer, right?
Yeah,
Okay.
exactly.
I just
Yes.
wanted to make sure because I
Yeah.
hadn't followed that yet.
Yeah. Let's look at that because that's a good question. So we're going to look at the services in Kong data plane, right? Actually, let's do Kong. I'm sorry, I'm going to say Kong and the Kong control plane. So essentially, we do have our proxy right here. You can see it. It is a load balancer. So it's directly connected out to some infrastructure. But yeah. All right. Okay, so product page, right? I keep talking about it. I'm beating around the bush because I don't know exactly how to share this because I want to show you the internet when I port forward to this. But here's what we're going to do. I'm going to go ahead and make an ingress here, right? So in Kubernetes, making an ingress is actually very simple, right? You say, okay, create ing, name of the ing, then you have a rule, and then you say, basically, creating ingress, we have a rule. So this is the actual host name. Do I want my host name to be google.com? Do I want it to be kong.com or whatever, right? Then we have our routes. In this case, it's just a forward slash. It's not forward slash product page, it's just a forward slash. And then we have the service. So this is the service in its own namespace because ingresses are namespace scoped. If at any time you don't know what is and is not namespace scoped, you can say kubectl API resources space namespace equals true or false, and then you can kind of grep for a given resource. But that's why ingresses are so powerful and they belong in their own namespaces for their own things that they're concerned about. So this book info ingress is concerned with book info. Right now, in order to hit book info, you're going to have to send a request with the actual host name being *.co. We're going to change that, obviously. Then you hit anything /. It's going to redirect you to the product page application on port 9080 and book info. Now we're going to do some more Kong specific stuff because Kong has a very powerful ingress controller called Kick, or Kong Ingress Controller. And we're going to go ahead and annotate this ingress to strip the path for true. Then next, we're going to, and this is the 100% essential, right? We would be able to get by just fine without stripping the path. This is a nice to have, but we do need an ingress class if we want to use Kong Ingress Gateway, right? So we're going to actually patch our ingress, and we're going to do basically an OP patch. And we're going to add the ingress class name as Kong. We're going to remove that host. There's just simply no reason. I mean, you can have a host. You don't need a host. If this was in production, I'd have like an actual TLS, and then in my like Google domains, I would be pointing to the actual IP address of that Kong proxy. And so basically, so I could say in Google domains, hey, route, when I say CaseyWylie.com, route to this IP address. That's kind of too long, too short, didn't read. But that's what we're doing here. We are essentially creating an ingress. We are patching it to include the ingress class name of Kong, and we're adding this annotation to strip the path. And now essentially what we're going to do is we're going to test this ingress, and let's do it. So this is all I'm doing right now is actually getting the ingress. I don't have PB copy because again, this is running on Ubuntu. But PB copy for you Mac folks out there is just a way to copy from the terminal. All right, so I'm going to, Kat, so can I share another screen?
Yeah, you know what? Because of the tool that we're using today, you might have to stop sharing and share a different one, and then I'll just make sure and share that out.
Perfect, okay. Okay, where are we again? Share, oops, wrong share button. Here we are.
Awesome.
All right.
Okay, so let me go ahead and share that out. So is this our application?
This is our application, right? This is the good old reliable, trusty book info application where essentially we have the details application. This is this microservice details. This is reviews, and these little stars are ratings. So essentially the requests are propagated through the cluster, and all the kind of information is piped back, and eventually product page has this information, right? Somehow product page has it. And really interesting piece of information here. So the amount of traffic that's north-south, so from the user into your cluster, versus the amount of traffic that's east-west. So I log in, I get a session, and then all these microservices start talking, is like, maybe up to 4 orders of magnitudes greater than the north-south traffic. So essentially the user sends one request, but then these microservices architectures have to do a lot more things for that to actually happen and get the information back to the user. All right, so we are going to now go back to the console. And so, I was talking a lot, but what happened there? We just exposed the application that we deployed book info through an ingress, right? And we're using Kong to do that. So what's the next thing? And I hate to do this to you all, but I do want to show you, this is so important, right? Rate limiting, because we're going to have to switch back to the browser in a second. But actually, no, we don't have to yet.
Yeah,
so don't worry
so that's actually really fun to stop and look at. What we're looking at, if you look at those first 2 lines of this YAML object, is the API version. And you can see that that's pointing at a Kong API, which of course is this one of the CRDs that defines what Kong can do. And the kind is the Kong plugin. So Kong has a lot of an entire storefront of plugins that are pre-built and ready to add features to your Kong deployment. And this one, of course, is the basic rate limiting plugin, right?
Yep, exactly. And so Kat, what would you say? Why do you want a rate limit? So why do you want a rate limit on a microservices architecture? What are you trying to prevent from happening?
So I like to think of rate limiting like being the oldest child in a family, which I was, of course, right? And I had three other siblings, and they would constantly be like knocking on the door. Hey, 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 cat, cat, I need this. I want this, right? As the oldest, it often fell to me to go ahead and like step in and save the day or whatever. And up to a point, that can be great. But when it happens too much, you want to give each consumer, right? Each person coming to that front door a limit of how many times they can knock on the door. Trust me, I wish I could have done that. And
Yes.
in real terms, we think of that any abuse of an API service or knocking on that front door. Um, a lot of times you might see something like DDoS, right? Denial of service attack. And that is where a nefarious actor, right, is knocking on that front door with the express intention of overwhelming your traffic um, handling abilities to deny everyone else's requests. Because if they knock on that door so many times, then you're not going to be able to answer the traffic of other legitimate requests. So that is one reason that rate limiting is really important, to make sure that you're treating everyone fairly and who you respond to when and how often.
That is, I could not have said it better myself. That was a great, great, perfect explanation. And this is thoughtful rate limiting, right?
No,
So
no
essentially,
bitterness if my siblings are watching, I swear.
yeah, yeah. Uh, what's up, Cat siblings? But so we're actually respectfully rate limiting. So essentially, rate limiting is protecting your critical infrastructure. Maybe your database can't handle quite as much as your Envoy proxy, right? It's different things have different throughputs, and we're respectfully rate limiting by IP address. So punish the people that are trying to attack your system and take you down. Don't punish the people who are trying to use your system, and you don't want to lose like money or users over it, right? So you
So,
want to punish.
and that by IP, that's based on the source address of the traffic. So, it's not based on the IP of the load balancer that's fronting the service. It's based on the IP where that traffic is coming from. Actually, it looks like we have a question. Can we
Okay.
prioritize requests when rate limiting? So, that's a bit of a QoS, like quality of service question. And yes, there are ways to actually identify who is making a request. Say you monetize your APIs and you have different billable tiers for who gets more bandwidth, who gets more a higher rate limiting ceiling, and things like that. You can actually understand who is consuming your API, who's knocking on that front door, and treat their traffic based on the policies that you define specifically for that incoming request.
Good explanation. So basically, we are leveraging this Kong plugin right now to rate limit by IP address, and we've said essentially we only want this is a service that we built that's terrible, right? That we know can't take any load. So we're saying like after 3 requests in a minute, it's probably going down. On that fourth one, it's
I
done.
guess normally it would be higher than that, wouldn't it?
Maybe.
No
Hopefully, right?
hitting F5 over and over and over on that service.
So I essentially just curled through the ingress over and over again until I hit this 429. And obviously 429 means, whoa, back off, too many requests. So basically it's gonna wait there's like a backup period. And probably right now I could probably send another request through. Yeah, I'm getting 200s back at the top, you see there. But you do it too many times, you're gonna trigger that rate limit. And
Yep.
there we are, 429. All right, so yeah, that's all about protecting critical infrastructure. Now we're going to talk about actually protecting your services and actually using JAT tokens to protect your services through OIDC.
Okay, so this is where we're actually not just saying you can only, knock at the door 3 times in a minute, but you have to have, the secret password and or the secret knock, right? And
Yes,
then you get let in. And this is we're going to be using looks like Keycloak as
yes,
our OIDC provider.
yes, exactly.
Okay.
Yeah. And if you're not familiar with Keycloak, it's a Red Hat product. It's open source. It's written in Java. It's been around a while, but it has a ton of functionality. And we are installing Keycloak from the operator. So like every single other application that should be, according to best practices, it's in this other namespace. So we're going to create the namespace Kong Keycloak. Are there maybe some edge cases where you can put two apps in the same namespace? Probably, I don't know. But, I'm a know-it-all sometimes.
You know what? I think you're opening a can of worms, because there are so many ways. I mean, people talk about pods and what, how big should a pod be? What all should live in a pod? For example, you can deploy Kong with the control plane, the data plane, the developer portal, the web UI, all of that in one home release, which puts it all in one pod. Or you can separate it out into tiny microservices, and then should they all live in the same namespace? Should you split each service out into different namespaces? It's all architectural debate at that point. What is correct for compliance in your organization, and what is correct for security purposes and isolation of traffic and such. And that applies to all applications, not just Kong.
So, first step, since we're installing this by an operator, operators for installation, they use something called OLM. So we're essentially, what we're doing here is we're installing an operator group. The operator group's job is basically to say, where will this operator live? And the subscription is basically where to find these operator manifests, these assets for the operator. So basically, we're just deploying this in the Kong Keycloak namespace. Oh wait, we already did that. So, and it came up, the operator is actually ready. All right, so here we go. This is going to be kind of a long thing, because it's going to be a total configuration. So Kat had this really awesome analogy, right? So we're knocking at the door. Now you actually have to have a key to get into the door, right? And we already know, just because you knock 100 times in a row, basically the door is going to disappear if you keep knocking. So now we're handing out keys. Hey, you want to get in? You can take this key. So first thing here, this Keycloak, this is an instance of Keycloak. So this is an instance of the operator. I'm officially now launching an instance of Keycloak. Next, I have a realm. A realm is how all your apps or all your users, it's another logical separation, right? It's not a physical barrier. It's what's called a realm, but it's how you do your logical grouping of users and applications, etc. In our realm, no surprising, is called the Kong realm. It could have been book info realm, but it doesn't really matter, right? Apples, tomatoes, whatever. We have our Keycloak clients, and we have our redirect URL. And this is, OIDC is just this spec that tells you how to do things on OAuth 2, right? So you have to have this redirect URL. What does that look like? What does this look like? Well, that is and this isn't going to work, because we're going to need our actual new ingress. But yeah.
So are you going to be serving the Keycloak at that address?
Yeah. Mm-hmm. This is going to be my redirect, and it's going to actually redirect. So basically, someone's going to come in, my Keycloak is going to push them back to the product page. So lastly, I have my Keycloak user, Kermit user. This user was created by a person that I was working with named Ruben Romero, that's from Red Hat.
It's not easy being green.
Yeah. Here we go. See if this works. And I just want to check this one more time. That's in Kong GP, just to make myself feel better. Yeah, this should work. Okay. Mm-hmm. Just see how the demo gods feel about me today.
I mean, they have been on your side this whole time.
That's true. That's true. Cool. All right. So, we just deployed a bunch of stuff. We just talked about what it is. Let's wait for it to come up.
Now I'm hoping that I deployed big enough instances. I think I've crashed EC2 that was too small with Keycloak before.
Yeah. Yeah. I mean, Keycloak's a big one, right? It's written in Java. It's not exactly like Dex, which is like probably faster, but
Yeah,
Keycloak has like a lot more stuff in it.
it does. Like its broker ability and all of that. It's a pretty powerful tool for sure. And I know I've used it with my customers in the field before.
Essentially, we're kind of in a standstill right now. We're waiting on this pod to come up. It's 100% going to come up. Just takes a little bit of time. Like, it's a Java app, right?
Yeah.
Love to do
Actually,
Java.
I just wanted to recognize we are coming up on the hour, which is normally where we end. I'd
Okay.
like to go ahead and stay on long enough to go ahead and show the OIDC in combination with the rate limiting that we already showed off here. So I'm going to keep the stream running for a little bit while we go over time. But I just wanted to thank everyone who's stuck with us so far and who have participated with good questions. If you have to drop off again, be sure and pick up the stream where you left off on YouTube, because we will be posting it when we close down the stream, and you can get caught up and see what you missed on YouTube later. Of course, any additional questions or comments that you have, I'll try to respond to those in the next few minutes before the top of the hour. We'll go into overtime, and if you have additional questions or things like that and you want to leave comments in YouTube, we will do our best to try and answer those things. We do, of course, have the Kong channel in the Kubernetes Slack, so you can follow up with us there. And then Casey, thank you for everything that you put together to show us today. I have had a blast seeing how you go about doing this on OpenShift. It's been a little bit since I exercised my OpenShift muscles. So
Hey, no problem. No problem.
I think
it
was 4.1 or 4.2 was the last time that I was regularly spending time on OpenShift. I was still doing like infrastructure work after that, but it was a little bit ago.
That's cool. That's cool. My heart was just skipping a beat when you were talking to me, because I was like, why is this thing not coming up? But hey, good old Java.
We made it.
Yes. 3 minutes later. All right. No, Java is actually really awesome. I'm not. Yeah. I mean, any programming language you want to use is perfectly fine with me. So now we are doing another Kong plugin, right? Which is very important. We're talking about Kong. And this is a really cool plugin. This is a really awesome plugin that allows you to essentially, when the request comes down the request path, what this plugin does is it's going to actually check for a token. If there's not a token, it's going to redirect you to the OIDC like login page. It's this Keycloak login page. And then you'll get a token, and then it'll redirect you back to the application. But essentially from here on out, or after we make this annotation on the ingress, our book info application is going to be protected by OIDC.
Actually, I wanted to add to that, because the question earlier about prioritizing request traffic based on different like quality of service rules and things like that, that token is one of those pieces of information that you can use in understanding who is making the request and treating them based on specific rules that you have established for either that user or that group, that you can understand as an individual consumer based on that specific token data point.
Okay, so we're kind of done for here for this moment. So I'm going to actually take you all back to the browser.
Let me get that shared out. Okay, so this is the page that we had before we implemented the OIDC, right?
Yes, that's correct. We're going to try to... A little slow right now.
All right, demo gods are going to show their true colors now, aren't they?
Right. Well, there's checking the logs in the back, but I don't see any errors right now. Let's see. No, it's going to work. I think it's just slow. I honestly do. Oh, sweet. This is good. This is a good thing. Let's go.
All right, and then of course we're skipping past insecure certificate errors and things like that. in a more mature deployment, of course, we could have used Cert Manager or AWS certificate tooling and things like that to automate loading SSL certificates into the Kong gateway based on service, or creating one that is a fallback, possibly wildcard certificate, things like that. So the not secure is what we're looking at right now for demos, but of course that SSL feature is built into the gateway itself too.
Yeah, exactly as Kat said. And I'm sorry about that. I should have thought, but I logged in through Kermit, the user that we created. And then I just wasn't thinking, and I just kind of stopped sharing my screen.
No,
But
you're fine.
For all intents and purposes, it works. It works just quite normally, I guess.
Yep.
All right, so we are done with Keycloak. Now we're really in the very end of this, right? We're in the end. The beauty of Kong Gateway or any powerful gateway and fast gateway like a Kong, or there's plenty of gateways out there that are also really good. But the thing is, these gateways are north-south traffic, and we don't have control right now over east-west, who can talk to who. So we can kind of finagle this a little bit, right? So we were essentially looking earlier at this infrastructure, the book info. And I'm going to do this fast. I'm sorry, I'm going to have to kind of switch back and forth to the browser, because I'm going to make a policy that says, I'm going to make a network policy that says deny all. Do not let anything into the mesh. And I'm not going to show it to you because that's going to be boring. It's going to be a blank screen. Just kind of like keep waiting, and it's not going to show anything. Then I'm going to make a network policy so anything can access product page. Then I'm going to make a network policy so product page through an ingress can talk to reviews. Then we're going to make a network policy so that reviews can talk to ratings through ratings ingress, through ingress traffic. Then I'm going to make one more network policy so product page can talk to details, and that's it.
So these network policies, is that an OpenShift specific API, or is that a Kubernetes general API that you're using to control that?
Yeah, so this is good old vanilla Kubernetes. You have to have a network plugin installed. So like I use Calico, you could use Cilium. There's a lot of them that support network policies. But basically, it's more like on a very lower level than like the Kubernetes level. And when you're installing Kubernetes, you have to have this like pod networking solution, or CNI, I believe it's called, present in the cluster. But yeah, I mean, I love OpenShift, but I try to keep it as generic and vanilla, as possible, because you never know what you're going to encounter in the wild when you're working on someone's infrastructure.
Right. And understanding those fundamental base concepts just makes it more powerful, even if you do also choose to leverage some of the OpenShift specific stuff.
Totally. So this is a denial network policy for the ingress. So basically, and it's in the book info. So there's nothing that's going to happen here through the ingress. Basically what it says, right? Don't let anything happen. No ingresses. And I'll skip this for right now. I don't want to switch too many times because I'm really at the end and I don't want to lose too many people. All right, so here's where we're going to actually be able to see something. We want product page, that front end seeming application. I don't know if it's like server side rendered or exactly how it works, but that front end application is going to want to talk to now. Oh, I'm sorry. So this one is actually ingress to product page. So product page essentially cannot speak to any other microservices after this network policy is applied. So we can actually hit the front end, but we can't hit any other microservice. So no reviews, no ratings, and no details. So stop sharing, come back to the browser. And so we're going to have to refresh this, obviously. And I don't know why it's a little slow for me right now, but it does.
Well, I know you are East Coast, and I'm pretty sure I deployed this in US West 2.
Okay, cool.
I want to say.
Well,
so
wasn't super latent, just a couple of seconds. But so that network policy I just created, I said basically product page can receive traffic from any pod, just open and close curly braces, right? Just generic. Anything can hit product page, but product page, basically the other microservices that are in book info are still locked down. So product page can't talk to reviews, product page can't talk to details, product page can't talk to ratings.
So,
Right.
so then that
Sorry.
was why we were seeing, of course, the actual errors and stuff on that page, right?
Yeah, exactly, right? So the way the front end is written, like it's just basically going to say like, can I query, can I not? If I can't query, it's going to say, sorry, the details are currently unavailable for this book. Product reviews are unavailable, because we've essentially started blocking traffic through network policy, and product page isn't allowed to talk to anyone right now. So let's allow it to talk to, product page has a best friend, and it makes me really happy to talk about product page and its best friend, reviews. Product page loves reviews, and reviews likes product page. So basically, in this next network policy, we're going to say this is an ingress policy, and it's on the reviews microservice, and it's going to say, okay, I'll accept ingress traffic from product page. So reviews has ingress traffic from pod selector match labels at product page. So we should see at least one of those blocks on the right side now becoming populated after this network policy is applied. Okay, we will stop sharing.
So now we're going in and basically whitelisting that one connection.
Exactly. Okay, it looks like we are sharing again. Okay, and what was that? That was reviews. Product page can talk to reviews. The last time we refreshed, there was an error fetching the product reviews. Now we should be able to talk to the product reviews, but we shouldn't have any stars. So we shouldn't have any ratings, but we should have the reviews. So our reviews are now good.
Reviews.
Right. Yep. So reviews has a best friend called ratings, and they don't like to be separated. So let's let them talk. All right, so review ratings, this is essentially going to just give you the stars, right? Because based on the architecture, it's reviews that talks directly to ratings in order for it to know how to populate those stars. We are applying, and that's going to just give you the stars. But we're running over. So I'm going to actually give you that left side as well. So it's saying now, this is the last network policy we're going to apply, and it's in the book info namespace. It's an ingress policy type, and it's applied on the details microservice. Basically, the details can accept ingress traffic from the product page. So now the product page is going to be able to reach out to details and kind of see those details for a given book. And after I apply this, and when I go back, we are going to be all done, and that's going to conclude our session. So let's thank you so much, everyone, for bearing with me, and thank you, Kat, for bearing with me and inviting me. It's been a fun run.
Blast.
All right, our last time that we were looking at this, ratings was a no-go, unavailable, kind of blocked off through a fence through this logical domain, right? And also, we of course couldn't talk to the details. Let's refresh. And now we're all good. Thank you all so much.
Yeah, that's a fully functioning app right there.
Yeah.
Well, Casey, you brought a lot today. We're definitely bold and daring the demo gods, and they blessed you anyway. So it was really fun to show all that off. I know we covered a lot of details. So we deployed a control plane. We talked about different ways that Kong itself can be deployed, and the fact that we were separating the data plane and the control plane today. We went in, we deployed the data plane. We added a rate limiting plugin. We deployed Keycloak and then configured Keycloak to authenticate in front of our application. We deployed book info to demonstrate all of that. And of course, that's a multi-service application. And then we went and we continued to tempt fate and applied a bunch of networking policies to show how you could control and make sure that nothing was talking to anything else unless it was very specifically supposed to, designed to, and allowed to. Casey, that was a great demo. You showed a lot
Thank
of
you,
the
Kat.
power of Kubernetes right there and whole, and it was really fun to see how Kong fits into that to give you access to all of those abilities. So bravo
Thank you so
and
much.
thank you.
Thank you. Thanks, everyone. Bye.
All right.
So should I drop now, Kat?
Yeah, go ahead. I'll
All right.
catch you on the flip side.
Okay, bye.